So number 8, the function f of t equals 310 times 1.025 to the 7t represents a change in quantity over 2 weeks. What does the constant 1.025 reveal about the rate of change? So we know that it's growing by 2.5% so t is weeks. So it's not 7 weeks because remember that variable, the x portion, it's opposite. So instead of 1 week, it's splitting into 7. So that's why it's days, because 7 times t is 7 times per week. So it's each day. I always think opposite, but like Ms. Sauer had written here, you can think of it in that way. It's however your brain processes it. Okay, number 9. Population of a small country is decreasing 0.575%. So remember, you got to move that decimal 2 places to the left. Originally, there were 576,800 people in the country. Write an equation to model number of people. So there's no compounding, nothing weird going on. So there you go. If you left it like this, 1 minus 0.00575, that's fine. That was, I guess, simple enough. Remember, this is called simple interest. You could have also used periodic compounding. I know some of you like to use that. Y equals P 1 plus R over N. So in this case, your N would be 1. So if you wrote Y equals P 1 plus 0.0, oh man, I'm going to run out of space. 575 over 1. Can I write over this? Look at that. Oops. Dang it. So NT would be 1T or just T. That's fine. It's the same thing. So if you just want to use the periodic compounding formula, that's okay. Number 10, a deposit of $2,500 is made into a bank that gets something. I can't see what I wrote. 43% interest. Compounded daily. Yikes. Write a function to model the amount of money in the account after T years. So we got periodic compounding. Annual interest, so 0.43. Compounded daily means 365 compounds, which is right here. Now it says, same formula, this one, write in the form y equals a times b to the t. Round to 4 decimal places. So you're going to take this piece, put that in your calculator. Remember to use the parentheses around your base. And by what percent is the account growing each year? So you take that base, 1.5369 minus 1, and that's what you get, 0.5369, and you move the decimal 2 places to the right. This problem doesn't look that difficult, but when you have to do this on your own in a testing situation, it can be tricky. That's why you got to practice. Okay, rabbits is increasing 136% per year. Write a function for the number of rabbits tiers after the population. Oh, wait. There's a typo in here. That should be 400. Reveals the quarterly growth rate. Okay. So here's our formula. You could use periodic compounding. You would just use a n equals 1. So we have 4. So our percent is 1.36. Since it's 1 plus 1.36, that's where this comes from. 400 times 2.36. Let me clear this all out. So now it wants the quarterly growth rate, not compounding. This is where you're changing time. So when we go from years to quarters, our time is getting smaller, so it's 1 over 4. So that's why in here it says 1/4. And then you have to balance that out with a 4 on the outside. So you put that in your calculator, and this is what you get. So remember that 4 T's out there, 4 times per year is every quarter. What is the quarterly growth rate? Base minus 1, so 23.9%. All right, I'm going to stop this and then do page 4.